Good morning, geometry students. Hope you've all had a wonderful spring break. It is Monday, April 13th, and we are shifting gears a little bit. Before spring break, we were tackling special right triangles, 30, 60, 90, 45, 45, 90, etc. Great fun. Before we jump into trigonometry, however, which is coming up very soon, I want to shift gears from talking about everyone's favorite three-sided figure to four-sided figures. So this is going to be probably just a 1 week, maybe 1.5 week little mini unit on quadrilaterals. You know what all of these names probably are: square, rectangle, parallelogram, rhombus, trapezoid, kite, etc. However, it's probably been a while since you've gone through truly classifying these and what they mean. So what I'm going to do is give a quick little demo to remind you what these all are. And you have two assignments. One is a Google slideshow that you need to move some things around and define some things just to make sure that you understand the notes portion of this. And then the second is a little 6-page packet. I know it sounds super long. It's not, I promise. And you've got till Friday to do it. So you'll be perfectly fine. Let's take a look. So this is the document that you need to save into your own name. First of all, up at the top, can you rewrite this to be your name? So Strawn, comma, Brandon would be mine. You would use your name. Similarly, on this first page, you're going to write in what your name is, and then the date. Let's see, I believe you guys use MLA format, don't you? So that would be 13 April 2020. Oops, and there we are, good to go. So let's take a look. This first one, and basically a lot of this is just going to be like click and drag, things like that. So for this one, we've got, and again, this is not difficult stuff. If you're looking at this going, oh my gosh, what are we doing this for? It's a review. Well, that's why. So the first one, let's see, a blank is both a rectangle and a rhombus. You know what? I'm not quite sure yet. That's a little too hard. So instead, let's see. Blank is a polygon with 4 sides and 4 angles. Ooh, right there is screaming that that is a quadrilateral. If it's not perfect, that's fine. Then let's see. A blank is a parallelogram with 4 right angles. Ooh, now that might initially make you think, ooh, square, but stop. Does it say anything about the length of the sides or just the length of the sides? No. So instead, that is actually going to just be a rectangle. There we go. Ooh, in fact, looking up here, a blank is a parallelogram with 4 congruent sides. That would be square. And a blank is a quadrilateral with 2 pairs of parallel sides. That is screaming parallelogram. And then a blank is a quadrilateral with 1 pair of parallel sides. Now that is what we call a trapezoid. And then a blank is both a rectangle and a rhombus. I made a mistake. Take a look at this. That is not a rhombus. Something went wrong. So let's see. Is both a rectangle and a rhombus? Well, a rhombus is not a rectangle, so that doesn't make any sense. So let's see if we can find where I made the mistake. A blank is a parallelogram with 4 congruent sides, a square. I mean, a square does have 4 congruent sides. However, does it say anything about the angles? It does not. So I'm going to move it down there. A square is both a rectangle and a rhombus because it has 4 right angles and 4 congruent sides. Therefore, rhombus actually has to go there. Now we finish that one up. Okay? I want you to try this one on your own. Again, you're going to be dragging those same things using the words that we just did for number 2. I want you to demonstrate what that looks like visually. Then in terms of classifying them for 4 and 5, we've got a couple of statements that we need to actually look at. So for instance, a trapezoid is blank a quadrilateral. Always. Otherwise, we wouldn't be talking about it. A trapezoid is a 4-sided figure with 1 set of parallel sides. And a trapezoid is blank a parallelogram. Well, let's see. How many parallel sides does a parallelogram have? 2. So a trapezoid can never be a parallelogram, period. A quadrilateral is blank a parallelogram. Sure, it sure can be, but it doesn't have to be. A parallelogram is blank a quadrilateral. Now that one has to be true. A trapezoid is blank a rectangle. No sir, no ma'am. Not gonna work. A parallelogram is blank a trapezoid. Polygon, well, it's always a polygon. A quadrilateral is sometimes a trapezoid, and a parallelogram is never a trapezoid. There we go. Let's continue. So then this one, you only just need to like write in the letters of them. So let's just pick a couple of them just for fun. So A, we know that the opposite sides are congruent because of the little dashes, but we don't know anything about the angles. Well, if they're congruent and the sides are, if opposite sides are congruent, that means that, think back to our parallel line postulates using transversals, we've got a whole bunch of alternate interior angles there, which means we have some parallel lines, 2 sets of them. That has to be a parallelogram. So I'm going to double click on the on the light green box down there and put A. Let's do one more. B. Well, does it have 4 sides? Great. Does it have any parallel sides? No. Does it have any right angles? Doesn't look like it. So we can just put that one. I'm going to double click down there at the quadrilaterals box and put B. And we're good to go. Okay, scrolling down a little bit further. Now here, we're just going to write all the different names that we can use for these things. And notice down here, you have in the notes, it tells you all the different names that you can use. So, spoiler, for the first one, you should think quadrilateral. It's a quadrilateral. Great. What else is it? Well, let's see. It also is a square, but every square is also a rectangle. And wait a minute, aren't the opposite sides congruent? And so that would make this also, wait a minute, aren't all of the sides the same? So like a square, but also this could be a rhombus. And since it's a rhombus, it could also be a parallelogram. Geez, this ends up being a lot of things. And let's see, can it be, we even skipped one. It's also a polygon. This ends up being a lot of things. Yes, it's a square, but it also is all of those things. Let's do one more of these. And I think that's basically the end of what you need my help with. Then looking at this next one. Well, this is definitely a polygon. It's definitely a quadrilateral. And let's see what else. So parallelogram. Nope, we need 2 sets of parallel sides for that. Polygon, already did. Quadrilateral, yes. Rectangle, we don't have any right angles. Rhombus, we do not have all the sides are the same. Square, definitely not. Trapezoid, yes. Fun fact, in Europe, they call them trapeziums. Is your fact of the day. And that's all we have for those. In fact, since those 2 sides are the same, this is called an isosceles trapezoid. Isosceles is basically the same thing as it means with triangle in that 2 of the sides are the same. Those 2 in the middle there that are the non-parallel ones will always be the ones that are the same. Think to yourself, why does it always have to be the non-parallel ones instead of the 2 parallel ones, which in this case are on the top and the bottom? It's a good way to think about this for a sec. Then scrolling down, okay, I'm going to jump down to number 11. Okay, circle the most specific name for each quadrilateral. And if you look at the directions down at the bottom, it gives you, just move it over and then you can stretch the circle. Great, so let's see. This first one, I see 4 congruent sides and I see no information about angles at all. To me, that is screaming rhombus. So I've dragged it over there, stretch it out. Shabam. Then let's see one more. I see opposite sides are congruent. Well, we had an example like that just a second ago. That is definitely going to be parallelogram. Okay, keep going from there. And then finally, this last slide, number 12. This one we just got to drag to the true and false. So let's see. I'm just doing one with you. Figures B, D, and E are the only parallelograms shown. B, is that a parallelogram? Yes. D, is that a parallelogram? Yes. E, is that a parallelogram? Yes. But now let's see, what about C? Is that a parallelogram? Definitely not. And what about A? Yes. A is a parallelogram. So we would therefore drag the circle over to the F. That is a false statement. And then you can keep going from there. Finish this, and then you can just share it right back with me. Next, for the packet. Again, there are 6 pages. The first 2 are pretty self-explanatory, but just in case, let me non-self explain them. Looking at this first page, note that for 1 through, 12, you just need to state the most specific name for each figure. You don't have to go through and say, it's a polygon, it's a quadrilateral, it's a blah, 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 or blah, blah, blah. For number 1, bam, parallelogram, and you're done. By the way, those little triangles on the parallelogram mean parallel. They do not mean congruent, they mean parallel. Looking down at number 3 then, I'm pointing at my screen as if you can see it, and you can't, but that's fine. Looking down at number 3 then, those 2 dashes, the top and the bottom, those mean they're parallel, and then the 2 dashes to the side mean they are congruent. By the way, quick side note, don't have a printer? Don't worry about it. Have a printer but don't want to use it? Then don't. You can just write the numbers out on a separate sheet of paper and write the answers in, and then just or either put that in like a Word doc and share that with me, or in a Google Doc and share that with me, or just on a piece of paper if you're like a big pencil and paper kind of person and you want to then take a picture of it and share that with me. So many different ways you can do this. Just the sky's the limit. Scrolling down though, I guess, or for many of you that might be turning the page to the back of it. The 13 through 18 on this page, however, does state all possible names, it should say S, names for each figure. And there you might want to take a look back at the Google Slides presentation. I'm so used to saying PowerPoint. The Google Slides presentation that you just turned in, because they look like they're very similar shapes to me. Not necessarily exactly the same, but very similar. Also, there's a new term in there, and that dates back to number 17. I don't want to give it away, but I will say it is one of my favorite songs from Mary Poppins at the very end of the movie where Mr. Banks says, "Let's go fly something." Okay, now let's do the bottom ones. Last little bit. Let's look at some of the rest of the pages in this. This is page 3. So let's see. Looking at number 1 on this page, find the measure of each angle indicated. Well, like, common sense is often a very handy tool in math. And so in this case, 100, 180 blank, well, indeed, to me, it's screaming that that has to be 80. Do we know that for sure? Well, let's find out. And in fact, to do so, let's come over here because I want to use this as an example. Remember that the number of angles in any triangle ever, those 3 angles, always add up to what? 180! Exactly. So, with every quadrilateral, we end up dividing them into, that was a terrible line, I can do so much better. We end up dividing them into 2 different triangles. That wasn't much better, but you know what? I'm going to go with it. It could have been there or there, whatever. Regardless, there's 2 of them, so instead of 180 degrees, it's 180 times 2. So 360 is going to be the big number that we are wanting to focus on here. So let's see, if we've got 120 plus 95, whoops, I wanted to add another as well, plus 85, so let's see, that's 17, 18, 19, 20, and then 200 plus 100 is 300, there we go. So our missing angle is going to be 60 degrees. Coming back here to confirm that our opposite angles are congruent, well, let's see. 100 plus 100 plus 80 plus 80. Is all of that going to be 360? Yep, we're good to go. Okay, you try the rest of these. Then It only gets a little more complicated for the next page. Basically, you just need to set them up as equations. I'm just going to do number 09 with you all. So let's see. We're going to do 86 plus 94 plus 94 plus 11x minus 2 equals 360, and then solve for x. Or, I wonder if there's anyone who noticed that that and that have to be the same, which means that and that also have to be the same. That is to say, 11x minus 2 equals 86. Solve for x, you're good to go. Now down here, however, this does not look like it's a normal shape to me. This is screaming, I'm not a parallelogram! And so instead, we've got our 90 and our 90, and then some goofy shapes over there. 98, so that's going to be something different. So let's say those two are definitely going to be adding up to 180, right? So let's ignore that, and let's say that 17x minus 3 plus 98 equals 180. Now we can use that, combine like terms, send that over there, divide by 17, solve for x, and you're good to go. Same thing for these bottom four. The only difference is instead of solving for x, they actually want you to then find the value. So you're going to first add that plus that plus that plus that equals 360, solve for x, and then plug in 2x plus 18, plug in your answer for x, and you're good to go. Suddenly this last page is probably going to look super easy. And for this, there's one last worksheet that I did include, but it's not a worksheet, it's actually just a notes page that has a whole bunch of different facts about quadrilaterals. You're going to use that to help you with this. So let's see, 135 and that, what is it? Well, if it's a parallelogram, it's just going to be 135, and that's it. If this is 80, then what is our adjacent angle going to be? Well, it's not 135. Use that worksheet, see if you can figure out what it's going to be. Same sort of thing here. I don't want to give these away, though. I want you to try to figure out as many of them as you can without my help. And I'm going to say the same thing for this last page as well. For the first one, they want you to solve for x, not unlike this first piece. And then at the bottom, they want you to actually find what is the length of RQ. So that one right there. Oops, just kidding. I misread. What is the length of RQ? What is that right there? And shabam, there we go. So, Mr. Strawn, all of a sudden you're giving us so much work. What the heck? Well, the reason is because you have until Friday to get all this stuff in. I will see you in the afternoons at 1:30. If you have any particular questions, if you want to go through them, I'm happy to answer those questions for you. So, thanks so much. I will see you guys again for another one of these videos on Thursday. Bye-bye.